Okay, moving on. The tree method is a very intuitive method to deduce or guess the solution to a recurrence. We'll study this probably at the end of this course, but I'm gonna hint कि अभी यहाँ पे क्या हो रहा है. Yeah, here's an example. इसको something like this we did in the last class. Okay. Okay. Let me just quickly do this here. So, do you guys see how to solve this recurrence using substitution method? So, what you would do is you would write T of n is 2 times T of n over 2 plus some n. Okay. You figure out what is T of n over 2. Okay. T of n over 2 would be what? 2 times?
2 T n by 4.
N over 4. Absolutely. 2 times T of n over 4 plus n over 2. Okay. And then now you want to figure out what's T of n over 4. Okay. And T of n over 4 is 2 times T of n over 8 and so on. Okay. And if you keep plugging this in, this will give you a pattern and you will have your answer. Okay. This is a nice way to visualize that thing. Okay. It's saying that when I make the first call, I'm going to spend this much time. Okay. And this n is coming from this thing. जो चीज़ मैं actually कर रहा हूँ, कुछ तो मैं recursive calls कर रहा हूँ ना. This represents my recursive calls. Okay. So it says that I'm going to spend n amount of time, and then I'm going to make 2 recursive calls. Okay. And then I'm going to do something. Right. Let's see what that is. So when you are here, this is the node where you are trying to do. You're trying to run your algorithm on an input of size n over 2. Okay. When your input is of size n over 2, what you're going to do is you're going to spend n over 2 time right there. Okay. And then you're going to make 2 recursive calls, each of size n over 4. Okay. So this tree will kind of outline the amount of time you are doing, or amount of the terms that are coming out of recurrence. Okay. So firstly I have so I'm going to do just plain substitution method. Okay. Hanan, pay attention. Okay. So this is just saying that this is 2 of n over 2 plus n. Okay. So this is the term that should bother me. This is the term जिसका मुझे नहीं पता क्या चीज़ है. Let's figure that out. Okay. So this term is T of n over 2 is 2 times T of n over 4. You guys just answered everything for me, so I'm gonna kind of not say everything out loud, but I'm gonna write it down here. It's 2 times T of n over 8 plus n over 4 T of n over 8. अब मुझे figure out करना है, right? It's gonna be 2 times T of n over 16 plus n over 8. Okay, let's plug these things in. Okay, so what do I get? I get T of n is equal to, so I'm gonna get this n. Okay, and then I'm gonna get n over 2, but this n over 2 is going to be multiplied with 2. Okay, so I'm gonna get 2 times n over 2. Then I'm gonna get n over 4, and this is going to be 4 times n over 4. You should know why this 4 is there. Fatma, why this 4 is there? Yeah, this 4 is this 2 times this 2. Okay. And then you're gonna get 8 times n over 8. Okay. Plus, अब ये वाली सारी terms cancel हो जाएंगी. You would have T of n over 16. Okay. You would have T of n over 16, but how many n over 16s? 2 times 2, 4 times 2 times 16. Okay. Just make sure it gets 16. It's not. So if I plug this thing in, I would get. So I'm going to plug this thing in. I would get 4 times T n over 4, and then I would get plug this in. I would get 8 times n over 8. Then I plug this thing in. I would get 16 times T n over 16. Okay. Good. This gives me a pattern. Okay. It says that the size of the input, the recurrence term, is being reduced by half each time. Okay. And the term that I'm spending is constant. It's n. Okay. Let's visualize this with a tree. So if you hate algebra, this you're going to love. Okay, so this n is this n. Okay, then I'm gonna make two calls. Okay, I don't know what I'm gonna do in those two calls. I'm just gonna make two calls. Okay, and for each one of those two calls, I'm gonna spend n over 2. Okay, n over 2, n over 2. Okay, okay. So at each of these calls, I'm gonna make two n over 4 calls. Okay, so I would have two calls for each one of them. This would be n over 4. This would be n over 4. This would be n over 4, and this would be n over 4. I'm going to make two calls. Each one is n over 8. Okay. This is infinity. This is not. Kind of. I don't know. Okay, and so on. Okay. Okay. What you need to pay attention to is that what you are going to sum up, what your answer is going to be is the sum of everything you have written in the tree. Okay, and at times it's very easy by looking at a tree. Okay, why? Because I know that at each level, this thing is called a level. This is the level 0. This is the level 1. These two are at level 1. These are at level 3, and so on. Okay, so at level 1 I spend n. At level 2 I spend n, at level 3 I spend n, at this level I spend, at each level I spend n. The recurrence में से जो term निकल रही है वो सिर्फ n है. Okay, so all I need to do is I need to find out the number of levels in my tree और इसको n से multiply करना है. Okay, that's how intuitive tree method is. Okay, all you need to figure out how big is this tree. When will this tree stop? This tree will stop when n becomes either 0 or 1. Okay, n will never become 0 because इसको हम divide by 2 करें, but n will become 1 at some point. Okay, when will n become 1? कितनी iterations के बाद? If you start with 1000 and divide the thing by half each time, how many steps would it take you to get to 1? So it's the reverse of this thing, है ना? It's the reverse or inverse of this function. This is being multiplied by 2 each time. What you are doing is you are dividing it by 2 at each time. Okay? What's the inverse of this thing? Yeah. Log of n. Okay? So is log n. And this gives you that this tree is going to be order log n. Super easy, isn't it? Yes? Ryan? What's making noise? Are we good? Question? Yeah.
जहाँ पे हमने डिवाइड किया और सिर्फ इसी केस में चलेगा क्योंकि मल्टीप्लाई करोगे या जिस तरह हमने वहाँ पे माइनस किया था अगर ऐड करोगे तो फिर वो इनफिनिटी तक जाएगा.
No. Let's do that. I wanted to spend 5 minutes on this. I'm gonna spend 15, I guess, but let's do it. So the last equation that we saw was, if I remember, it was t of n is equal to 2 times, I think, was it 2 times? T of n minus 1? A की form में था, I don't know. A of n was, what was it? Was it 2 times A of n minus 1 or just A minus 1? Plus something. You don't remember, right? Where is it? A of n minus 1 times 2n. Okay? A of n minus 1. So A को मैं यहाँ पे t लिख रहा हूँ, okay? It's fine, right? Am I allowed? Okay. Time 2 times n, okay? Sorry, what? What? Okay, cool. So let's try to solve this using tree method. Okay. So what is it saying? How much time am I spending at the root node? You. हाँ, दोनों में से कोई एक बात बता रहे हैं. So what should I write at the? यहाँ पे मैंने n लिखा था ना? What should write at the top? How much time I'm doing at this step? n की फॉर्म में, हाँ 2n, या सो आई एम एक्चुअली डूइंग 2n और उसके बाद आई एम मेकिंग अ रिकर्सिव कॉल, है ना, ओके, आई एम ओनली मेकिंग वन रिकर्सिव कॉल, है ना, सो आई एम जस्ट गोना राइट दिस, ओके, इस ट्री का सिर्फ एक चाइल्ड है, ओके, ओके, यहाँ पे मैं क्या लिखूँ? So this is, if you remember, this is a call that represents t of n minus 1, है ना? Okay. So when n is n minus 1, okay, I would get t of n minus 1 is t of n minus 2 plus 2 times n minus 1. So I write 2 times n minus 1 here, okay, and then I would get a call which is t of n minus 2. There's only one call, okay, so I would write here 2 times n minus 2 and then 2 times n minus 3, and this will keep going until I reach n is equal to 1 or 0, okay. यहाँ पे so देखो जो आपकी रिकरेंस होती है ना, एक उसका रिकरेंट पार्ट है, ओके, विच इज़ द रिकर्सिव कॉल, उसके अलावा आपका एल्गोरिथम क्या कह रहा है, उसका एक टाइम होता है, ओके, जो उसी रिकरेंस में लिखा होता है. सो फॉर एग्जांपल यहाँ पे ये रिकरेंट कॉल है और इसके अलावा जो चीज़ लिखी हुई है that's the time you are actually spending at that call, okay, ठीक है, okay. So उसके बाद जब आप ये वाली कॉल करेंगे ना t of n minus 1, आप एक रिकर्सिव कॉल करेंगे और आप 2 times n minus 1 टाइम स्पेंड करेंगे वहाँ पे, okay. So that's what I'm writing. So this is your answer. इस केस में you cannot multiply it with the height. You have to write the whole thing, but it's still simple. It's just 2 times I, where I goes from 1 or 0 to n, okay. So it's kind of the most efficient way to intuitively grasp what's going on in your algorithm, okay. Hanan, you can bring it to 0. I stopped at 2 is equal to 1. I should go to the last one, which is a of 0, which is just known to be 1, okay. So देखो लास्ट टर्म में आप इंडेक्स पुट नहीं करते, लास्ट टर्म में यू plug the value from the stopping condition. 1 plus this summation, yes. Okay. हमने यहाँ पे n से मल्टीप्लाई नहीं किया. हाँ मैं बताता हूँ, यहाँ पे जादू ये हुआ है कि ना यहाँ पे हर लेवल के ऊपर वैल्यू सेम आ रही है, वहाँ पे ऐसे नहीं है. यहाँ पे वैल्यू 2n है, यहाँ पे 2 times n minus 1 है, यहाँ पे 2 times n minus 1 है, so on. यहाँ पे भी मल्टीप्लाई नहीं कर रहे हैं हम इनको ऐड कर रहे हैं, लेकिन हम सिर्फ ये देख रहे हैं कि ये कितने n है. चूँकि वो सारे के सारे एक जैसे हैं तो हम उनको मल्टीप्लाई कर सकते हैं विद द नंबर ऑफ n's there are in this tree. Are we good? क्या?
यहाँ पे 2 branches के ऊपर ये क्योंकि डिवाइड, अगर यहाँ पे डिवाइड 3 से हो रहा हो रिकर्जन.
सो यहाँ पे जो नंबर है ना जो मैंने मिटा दिया है वहाँ पे है वो विच इज़ t of n is equal to 2 times t of n minus 2 plus n. This is what you write at this node and this is the number of branches you make, okay. So if you have a 3 times यहाँ पे तो यहाँ पे you would have 3 branches, okay. यहाँ पे 4 होंगी तो you would make 4 branches.
और रिकर्जन हमारी सिर्फ डिवीजन और सब्ट्रैक्शन की केस में कॉल होती है, अगर एडिशन या मल्टीप्लिकेशन हो रही है.
बोलो कोई बताओ एग्जांपल दो.
इन्फिनिट तक ही चला जाएगा
एग्जांपल. ओह ओके, तो वो एक इन्फिनिट रिकरेंस है, ओके. सो अगर आपके पास अगर आपके पास t of n is equal to, ये किसी को नहीं नज़र आ रहा होगा so I'll read it, t of n plus I don't know 5 है, तो this is infinity. यहाँ पे n plus 1 लिखना चाहते हैं, यहाँ पे आप n या n से बड़ा कुछ भी लिख दें, this will become infinite.
और अगर हम उसके अंदर करते हैं जिसमें स्टॉपिंग कंडीशन हमने ली थी यहाँ पे n0 is equal to 1 है ना,
हाँ.
अगर हम उसके ऊपर कोई बड़ी वैल्यू रख दें और उसके ऊपर स्टॉपिंग कंडीशन ले लें, मतलब 0 की जगह अगर n पॉजिटिव के ऊपर स्टॉपिंग कंडीशन रखें.
सो ऐसा यूजुअली होता नहीं है, राइट, क्योंकि फिर आपको बताना पड़ेगा कहाँ से स्टार्ट हो रहा है कहाँ पे ख़त्म हो रहा है. आपको स्टार्टिंग कंडीशन बतानी पड़ेगी, एंडिंग कंडीशन बतानी पड़ेगी. वो ऐसा रिकरेंस उस तरह की होती नहीं है. रिकरेंस का मतलब ये है कि आई नो समथिंग इन द फॉर्म ऑफ एन एंड आई वांट द टोटल सोल्यूशन, ओके. और इसका ये होता है कि आई वांट recursion में यही होता है ना कि you get a problem, you do something with it, and then you try to solve the same problem on smaller subset. Okay, so usually you can make a problem which would make sense, but in general it does not make sense to have a recurrence on a size of input which is larger than the original size. Okay, yeah, or even the same size. Okay, should we move on? Okay, let me see. Yeah, I think this is what we did. Yeah, and this is kind of what you guys did. Okay.